Hi, we are Group 3 and today we are going to present our solution, which is Gas Leakage Detection System. My group members are Chu Xiaoming, Andrew, Korweiler, Sun Wei Ting, and my name is Tan Jia Yong and I'm going to introduce the solution to you. So first of all, Gas Leakage Detection System is a system where it monitors the gases and alerts the user if it detects any gas leakage. So why do we choose Gas Leakage Detection System out of all those cloud-based solutions? Nowadays, we humans have been using a lot of natural gases and liquefied petroleum gas in our daily life. The leakage of these gases can lead to explosion and result in both material loss and human injuries. This is because gas leakage is actually a serious problem to us and can lead to various accidents. Next, gas leakage detection is first used back in 19th and early 20th centuries when the effect of harmful gases on human health were discovered. And gas leakage detection system is used in many applications such as residents, industries, and automobiles. And that's all for me. Thank you.
Hi sir, my name is Chu Zaming Andrew. My student ID is 17ACB02630. I will be presenting on the problem statement and the objective of this project. Okay, the problem statement of this project is gas leakage at higher levels can cause harm to human body and causes explosion when mixed with gases. Most gas leakage detection systems are built locally. The system is deemed wasteful if there are no authorized personnel in that area. Next, the objective of this project is to develop a system that allows different users to sign up and sign in, develop a system that will notify the user when the carbon monoxide level is dangerous. Lastly, develop a system that can allow users to monitor carbon monoxide levels in different locations.
Greetings to Sir Michael and my fellow audience. My name is Sun Wei Ting and I will be presenting the proposed solution of a gas leakage detection system. So let's begin. As you can see, this is the architectural diagram of our system. Our system consists of four main functionalities. With these functionalities combined, a fully functional gas leakage detection system can be created. The main four functionalities of this system are notification handling, which is the red block, database storing, which is the green block, authentication, which is the orange block, followed by data analysis, which is the blue block. Let's start by discussing the red block, which is notification handling. Notification handling will trigger whenever any sensor publishes a message to a specific topic for Amazon SNS in AWS IoT Core. This message will be in the form of JSON, which contains information of the sensor, such as location and current carbon monoxide level. From there, the AWS IoT Core will send the information of the sensor to Amazon S3 to update the information of the sensor. This Amazon S3 bucket serves as a storage for sensors to store all their information. With that in mind, whenever new info is uploaded to this bucket, it will trigger the AWS Lambda function. This AWS Lambda function will extract the newest info received from the bucket and make decisions based on two scenarios. If the current carbon monoxide level is lower than 40, then the notification process ends here. Otherwise, the system will publish a topic to Amazon SNS. If so, the topic published will then be sent to the people that are subscribed to this topic through email. This whole process is to notify the owner on the current carbon monoxide levels of their sensors when it is high. Moving on, let's talk about database storing. Like the previous function, database storing will occur whenever any sensor publishes a message to a specific topic for this purpose in AWS IoT Core. Note that these two functions trigger based on different topics. Once AWS IoT Core receives a new message, it will once again trigger an AWS Lambda function to send the information received and store it inside Amazon DynamoDB. The table in this Amazon DynamoDB not only serves as a purpose for storing database of all information of the sensors, It also has two other purposes, which are to display the information for owners to see in authentication and visualization in data analysis. Next, I will talk about authentication. First, users of this system will have to sign up and then sign in to Amazon Amplify, supported by Amazon Cognito. Amazon Cognito is used in this function to house all the info of users who sign up to monitor their sensors. Amazon Amplify acts as a web service for users to sign up their preferred username or email and password. So without Amazon Amplify, users would need an Amazon account to access AWS Management Console to sign up or sign in. After signing up, users will need to validate their email. Once their account is validated, they can log in to their account. From there, all their sensors are displayed at the web page of Amazon Amplify using Amazon Amplify. Users are also able to register their sensors into the system. The backend is handled by an AWS Lambda function, which will retrieve the user ID of the current user and compare the user ID of the owner of the sensors in Amazon DynamoDB. From there, the sensor information such as location and carbon monoxide level is retrieved and sent back to this AWS Lambda function. Then this AWS Lambda function will use the information obtained and display it onto the web page hosted by Amazon Amplify. This function will allow users to monitor their sensors when they are not physically present in the location. Finally, data analysis is an important function for stakeholders to have a look on the data stored in the system. First, Amazon DynamoDB is initiated and all the data in it will be sent to an AWS Lambda function. This AWS Lambda function will then be queried using Amazon Athena. Amazon Athena is used as the dataset of what we want to visualize. However, if the dataset used is stored in Amazon S3 bucket, these steps can be ignored as Amazon QuickSight allows Amazon S3 to act as a dataset. From there, Amazon QuickSight will use the dataset obtained from Amazon Athena and create visualizations based on it. That's all for my part. Thank you.
Hi, my name is Koala and I'll be presenting the future work of the project. First of all, different type of sensor can be added into the system so that it will retrieve different type of information, for example like temperature and also the humidity. This will help the user to visualize more information so that they will know more about the laboratory or also the factory. Besides, different type of sensor can also detect different type of dangerous gas which will cause a serious incident to happen. This will prevent the incident from happen and also improve the safeness of the factory and the lab. Besides that, a more interactive interface can be created on the system so that the system can have a better visualization on the information to the user. The system can also display more information to the user by having the interaction with the user. This will help the user to get easier to process the information and get know about the information of the lab and the factory easier. Lastly, instead of web application, the system can also be created in the form of mobile application as well. This will help the user to get easier to access to the application and have better monitoring on the sensors. If there are serious incident happen or there are gas leakage happen, the system will acknowledge the user faster by sending the notification to the mobile instead of email to the user, which not every user will access to the email every time. This will prevent some serious loss happen to the user as well. That's all from me. Thank you.